Hi everyone, my name is Yuchen, and we are presenting a new text generation challenge for generative commonsense reasoning. It's a joint work by USC, SI, UW, and AI2. What motivates our research is that the most current commonsense reasoning datasets mainly focus on discriminative reasoning problems, such as commonsense QA, the SWAG dataset. However, humans not only use their common sense for understanding text, but also for generating sentences. We thus propose a new dataset named CommonGen. As we can see, an input to CommonGen is a concept set, which is a collection of the objects and action words. For example, a dog, a frisbee, the action catch, and the action throw. The desired output is a sentence that describes an everyday scenario in our daily life using as many given concepts as possible. A simple example like the second one, a dog catches the frisbee when the boy throws it. Why is this problem hard? First of all, it needs much relational common sense knowledge about given concepts, and they are latent and compositional. For example, we can see this particular real example in our dataset. We need to know a list of facts which are latent and find the best composition of them for writing the final sentence. A woman in a gym exercises by weaving ropes tied to a wall. We analyze our dataset and find that it covers different types of knowledge, such as spatial knowledge, human behaviors, the object properties, and other general ones. Second, the dataset needs compositional generalization ability so that it can work for unseen combinations of concepts. For example, in the training time, we can see such examples about apple bag put, apple tree pick, apple basket wash. While in the testing time, the model needs to deal with a more challenging example like this one: pear, basket, pick, put, and tree. The model has never seen the concept pair in the training time, or the combinations of any two of the given concepts. While we still hope the machines can generate a sentence like a girl picks some pear from a tree and put them into a basket. So this is also some statistics of our dataset, and note that all the concept pairs in the testing examples are not shown in the training before. We have tested a comprehensive list of models on our dataset. These are some experimental results with several automatic evaluation metrics. We also did manual evaluation by asking humans to compare and rank the model generations. In the end, we found that T5 large, after fine-tuning, performed the best, but it's still far from human performance. This is a case study for qualitative analysis of the model generations. We can see that there is still a gap between humans and model generations. For example, the sentences written by humans are more natural and commonsensical in our daily life. However, if you look at GPT-2, it's like hands washing soap on the sink. Or Bird-Gen, a woman washes her hand with a sink of soaps. So these are less natural or plausible in our daily life. We also did some transfer learning analysis. We used CommonGen models to generate some choice-specific context sentences for the downstream applications, such as commonsense QA. And we found that the best models like T5, BERT, and UniLM, they can be very helpful for generating additional evidence for downstream applications that needs common sense reasoning. Thank you very much for listening. There are some links to the paper and the project page, and you can email me for more questions.